Today, I'm going to talk about connecting capacitors in series and in parallel. Now, in previous videos, we talked about connecting resistors in series and parallel and how that works. Quick review, if you put two resistors in series, how does that work? Let's say I have 100 ohms and 100 ohms. What do I get? You just simply add them up. You get 200 ohms. What happens if I put two resistors in parallel? Well, if the resistors are equal, the total resistance is 1/2 of either resistor. So these two resistors together are 50 ohms. And there's a formula to calculate that. That is the product over sum. So we take 100 times 100 over 100 plus 100 here. And we do the math of magic, and lo and behold, we come up with 50. And we can only do that with two resistors at a time. So if there's three, we have to do two of them, then put those two in with the next one. We have to do several steps. And there's also the reciprocal formula, where the reciprocal of the total resistance, represented by R sub T, is equal to the reciprocal of all the resistors. So they'll call this R1 and R2. So R1, R2, etc. So I take the reciprocals of those resistances, add those together, then take the reciprocal of that, and lo and behold, I have the total resistance. I went over that in a previous video. I'm not going to go into details on that again, but just a quick review of resistors in parallel. Now let's see what happens when we put capacitors in parallel or series. So let's take two capacitors in series. Let's say these two capacitors are 100 microfarads each. Okay, so what do we have here? Well, what makes this 100 microfarads? It is the area of the plates and the distance between them. And if we look at these, it looks like the plates are about the same, but if I look at here, it looks like these two plates are basically shorted together with this wire. So they're basically, adjacent. So essentially what I've done is I've got one capacitor where the plates are twice as far apart. So I took this and took out the middle and squeezed it into that. So essentially what happens when you put capacitors in series, you're taking that total plate area and moving them further apart. So if you move the plates closer together, you get more capacitance. If you move them apart, you get less capacitance. So if I put capacitors in series, I get less capacitance. So resistors in series, we just add them together. But capacitors in series are like resistors in parallel. So remember that mantra. Capacitors in series are like resistors in parallel. So I take these two 100 microfarad capacitors, and those two capacitors together are equal to half of either one. So those are 50 microfarads. And the formulas for resistors in parallel work also. So we have C1 plus, that's product over sum, C1 times C2 over C1 plus C2 equals our total capacitance. Or the reciprocal formula works too. So 1 over your total capacitance, C sub T, equals 1 over C1 plus 1 over C2. So the same formula that works for resistors in parallel works for capacitors in series. So what happens if we put capacitors in parallel? So there's two capacitors in parallel. Let's make them 100 microfarads each. And, well, it looks to me like I got the distance the same in them, but I have twice the plate area. So I have increased the amount of capacitance by increasing the plate area. So by putting capacitors in parallel, I actually increase the capacitance. So just like resistors in series, I simply add them together. So capacitors in parallel are like resistors in series. So together, these make 200 microfarads. So simply add them together. So capacitors in series are like resistors in parallel. Capacitors in parallel are like resistors in series. So just as a quick exercise, let's do a little problem here. Let's say I have this circuit. A combination of capacitors in series and parallel. Let's make this 100 microfarads and make each of these 50 microfarads. Doing this to make the numbers easy. Well, these two capacitors are in parallel with each other, so like resistors in series, I simply add them together. So together those equal 100 microfarads. And those are together in series with that one, which is another 100 microfarads. So capacitors in series are like resistors in parallel. So now these together are 100 microfarads. Those are in series with that one. So that all together is 50 microfarads. Now one thing you might see, this is a practical application actually, although I've seen it on tests. It's not just a question to make you think, it's actually got a practical application. What if I'm making a repair to a circuit and I need a capacitor that's 100 microfarads at 50 volts? So I need So I have a capacitor. The bad capacitor is rated at 100 microfarads and 50 volts. I don't have a 100 microfarad capacitor at 50 volts, but I do have 100 microfarads at 25 volts. Well, here's an interesting thing about that. If I put capacitors in series, let's say this is 25 volts and 25 volts. Well, the voltage rating has to do with how far the plates are apart. The further apart they are, the higher voltage they can handle. So just like calculating the capacitance, this is acting like one capacitor with the plates further apart. Well, it's like I've doubled the plate distance. So I've doubled the voltage capacity. So by putting two capacitors in series, I double the voltage. So let's say I have two capacitors that are 25 volts and 100 microfarads. I need 100 microfarads at 50 volts. So what do? I put two in in series. And so that's 25 volts, 100 microfarads, 100 microfarads. Now it's good for 50 volts, but how many microfarads do I have? Capacitors in series are like resistors in parallel. The total capacitance is, well, in this case will be equal to half of either capacitor. So I've only got 50 microfarads. I need 100. What can I do? Well, I have a whole box of these capacitors. So I get two more. Ain't this tricky? 25 volts, 100 microfarads, 100 microfarads. That's an F there. So these together are 50 volts and 50 microfarads. These together are 50 volts and 50 microfarads. So I have a 50 microfarad in parallel with another 50 microfarads. Capacitors in parallel are like resistors in series. I just add them together. So all together, I have 100 microfarads. So I have to have all four of these 100 microfarad capacitors, two in series, all together in parallel. I still have only 100 microfarads. But because of the distances, I now have a 50 volt rating for the two capacitors. So that's kind of a question you might see on a test. I know particularly the FCC GROL test has a question similar to this, except you end up with like 12 capacitors making up what you need. But hey, if you're in a pinch, you do what you need to do. So knowing these rules about capacitors actually can be quite useful of multiple capacitors in series and parallel. So anyway, So capacitors in series are like resistors in parallel. Capacitors in parallel are like resistors in series, and we can calculate the total capacitance. One more practice just because we can. How about 3 capacitors in series? Let's say we have 200 microfarads and 200 microfarads and 100 microfarads. So just quick off the top of your head, what's the total capacitance here? Well, these two together, like resistors in parallel, will be a total of 100 microfarads. So there we have 200 microfarads in series. Total capacitance is equal to half of either one, or we can use the formulas if they're not the same capacitance. And lo and behold, now I've got 100 microfarads in series with another 100 microfarads. So these together, 100, 100, like resistors in parallel, I end up with 50 microfarads. So that's capacitors in series, and useful to know, especially when you are trying to fix something and you have what you have and you need what you need. You can cobble together what you need from what you have. If you found this video useful and informative, please give me a thumbs up down below. It really helps the channel. And subscribe, because that not only informs you when I put new videos up, but it really helps the channel also. And a big thank you to my patrons at Patreon. I could not make these videos without your support. If you want to help me put these videos online and keep real vocational education free at vocademy.net, you can go to patreon.com/join/vocademy and pledge your support. And again, a big thank you to my patrons who make this possible, and a big thank you to everyone for watching.